Okay, so we really have two things left to do that both come from chapter 11, and they're not even really related to each other at all. And we don't, we're going to spend one day on one of them today and one day on the other Friday. And so we don't really give it that much time to do much with it. We're basically just trying to, fill the square to say that we've done it before the SOL. There might be a question or two on each one of these, not that much, and they're probably not that hard of questions anyway. After we finish that, then we have a review and test for the chapter of stuff. Then I was told today that the second, well, probably for us, it would be the 3rd of April, which is the day before spring break. We're being expected to take some kind of benchmark thing. I mean, they said they canceled the benchmark. So I imagine they think that this thing doesn't count for a grade or something. I really don't know. I don't pay much attention to what they say. But that's what I think that where we're heading right now. So we won't do any more new material until after the SOL. And the first day of the SOL testing window, I was just told today, is the 18th of May, which is, to me, too long, but whatever. It sounds like maybe they did, because it was supposed to have been earlier than that. I know, somebody wrote me today and said it was the 18th. Maybe they delayed it. But maybe, and that person might have been wrong. Because I did, when I looked at their calendar a while back to see, it said the 18th, the Hampton City Schools calendar says it's the 18th. But when I asked the testing lady about it, she said, oh no, it's not that, it's the 7th. So maybe the person today was looking at the same wrong calendar that I was. In any case, today we're doing this permutations and combinations, which I'm sure you would rather be doing rather than rational functions or radical functions or something like that. Okay, the first thing is the fundamental counting principle says that, for example, if you have 3 pants and 2 shirts, then you have 3 times 2, 6 possible outfits. I mean, it's almost, you didn't need a principle to tell you that, right? A principle, PLE, not PAL. If you have the first pair of pants and you could match it up with the first shirt or the second, you've got the second pair of pants that matches with the first or the second and the third. So the total number of outfits are 6. It's whatever it is, 3 times 2. I mean, typical kind of questions like this are, you go to a restaurant, there's 3 drinks and 5 entrees and 4 desserts. How many different kinds of meals could you have, right? And so you just multiply 3 times 5 times 4. Done. Okay. I mean, if you understand, this is the first section in a chapter, which is probability and statistics. And this is supposed to be somewhat leading to probability, in that, let's say you know that there's 6 possible combinations. You could say, well, what is the chance that you were wearing the first pair of pants and the first shirt? Well, if there's 6 total possibilities, that was 1 out of 6. That was the probability, 1 out of 6. First, you need to know how many total chances were there. What is the probability you were wearing shirt number 2? 3 out of 6, so you'd say 50%. 3 out of 6, 1 out of 2. So that's what this stuff is in here for. Okay, this example shows 2 license plates. One of them is from 1912, and then this is a current 2004 Maryland license plate. And the question is, how many more different combinations of license plates numbers do you get in 2004 than you got in 1912? Well, take this one first. If you only have 4 digits, and each one has how many different possibilities for filling it? 10, right? So you would have 10 possibilities here, 10 here, 10 here, and 10 here. So how many total choices? 10. It is 10, not that. That's good. 10 times 10 times 10 times 10, which is 10,000. Okay, this one's got 3 numbers, and it's got 3 letters. How many choices do you have if you're using letters to fill each spot? 26. So you're going to have to go 26 times 26 times 26 for these three, and then 10 times 10 times 10 for those. Right? How many is that? Shane going to do it? $17,576,000. 17,576,000 for this format. Okay, so the question was, how many more were possible in 2004? Subtract, right? So the subtract will be 17,566. 17,566. Piece of cake, right? So do it. Go ahead and do these three problems. These are homework. It's not you try. This is your homework. It's page 678, 9 through 11. If you got your book and you'd rather look there, these are copied from the book. Sure. So hurry up. We're going to move on. Shouldn't take you that long, right? I mean, I think 9 and 11 were pretty straightforward. How many? What did you have to multiply together for the 10? 26 times 10 times 10 times 10. So what was that? 26,000, right? Not tough. Are we okay with that? Okay. Next, how many different ways can we arrange 4 distinct items? Like if I have 4 books to put on a shelf and I can put them in any order, how many different orders are there? So I'm going to do that by filling these blanks. And I've just called, my 4 things are 1, 2, 3, and 4. So that's one order. Okay, now I'm going to like systematically go through and change places, right? So if I have a 1 in the first position and a 2 in a second, I could either have 3, then 4, or I could have 4, then 3. Anything else I could do with a 1 and a 2 in the first 2 positions? No. So now I'm going to keep a 1 in the first position, and I'm going to have the 3 in the second position. And now what will I have in these 2? I could either have 2 and 4, or I could have 4, then 2. That would be a different order, right? And then what are the last 2 going to be? 1, 4, and then what's in these 2? 2, 3, 3, 2. Okay, is there any other possibilities with a 1 in the first position? No. So we're done with that. Now let's do 2s. So this column is going to be all starting with a 2. Okay, so now just systematically, I'm just starting with the lowest. If I have a 1 in the second position, then what's the possibilities for the third and fourth? 3 and 4, 4 and 3. Okay, if I put a 3 in the second position, then it's 1 and 4, 4 and 1. If I put a 4 in the second position, 1, 3, 3, 1. Okay, now if I do 3 in the first position, then I could have 1, 2, 4, 4, 2. 2, 1, 4, 4, 1. 4, 1, 2, 2, 1. And last column, 4s. And so I'll start with a 1, 2, 3, 3, 2. 2. 1, 3, 3, 1. And 3. 1, 2, 2, 1. So we found all the ones we could with a 1 in the first position, and then the 2s, and then the 3s, and then the 4s. How many different orders did we come up with? 24. There's 4 columns of 6. And in fact, if you break it down even further, right, there's 4 columns here. And then within each column, there's 3 groups of 2, right? There's 2, 2, and 2. So the total is 3. So in fact, the number of possible orders of 4 things was 4 times 3 times 2, which is 24. Okay, see ya. Good luck. Okay. Okay, if we were going to arrange 10 distinct items, then it would be 10 times 9 times 8 times 7 times 6 times 5 times 4, right? However many items there are, that's what you're going to do. You're going to multiply that number by the number that's less than it, and then 1 less than that, and then all the way until you get to 1, although the 1 doesn't really matter because 1 times anything is same thing. Okay, when you do that kind of operation, like with 10, that's called 10 factorial. It's an exclamation point, represents multiply 10 times every number less than it until you get to 1. Factorial, that's what it's called. In general terms, and I had a mistake here, that should be a minus. N factorial is n times n minus 1 times n minus 2 times n minus 3, all the way down to 1. Now, most of these things that we're doing today and Friday, honestly, you're not going to multiply 10 times 9 times 8 and all that. You're going to put it in the calculator. And you're not even going to go 10 times 9 times 8 times 7. You're going to go to this menu, Math, Clear, Math, and you scroll over to the PRB, and you look at option number 4. There's your exclamation point. So it'll do that for you without you having to fat finger it in. Okay. So if I want to do 10 factorial, first I type the 10, then I go Math, PRB, 4. So you have 10 exclamation points. And that does the work for you. 3,628,800. So if you want to know how many different ways you can order a set of things, you do factorial. 3,628,800. Okay, when you count the number of different ways you can put things in an order, that's called a permutation. And if you read this problem, which is their example, it says, how many ways can you file 12 folders? Okay, And it says, use the fundamental counting principle to count the number of permutations. The number of permutations. Permutations means orders, right? Every individual, that's a permutation. And since there's 12 folders, you would do 12 times 11 times 10. I mean, when they talk about the fundamental counting principle, what they're saying is, okay, that means I can put how many different folders in the first position? 12. Okay, well, if I've already put one in the first position, then how many can I put in the second position? 11, right? Okay, well, after I put one in the first and one in the second, how many can I put in the third position? 10. So in the end, you end up getting the same math, 12 times 10, 11 times 10, all the way down to 1. But you just put it in the calculator with the factorial and get that answer. Try to, what'll be the math again for this one? How many ways can you arrange 8 shirts? What'll be the math? 8 factorial, right? 8 factorial. However many things you're arranging, that number factorial. And how many did you say it was? 40,000? Say again? I still can't hear. 40,320. So go home and try it with your 8 shirts, okay? Tell me when you get to 40,000. Okay, I don't think you want to do that. So go ahead and do these. These are added on to the homework. Right, 3 of them are just straight factorials, and then here's word problems talking about how many ways can you arrange your 4 tires on the car. How many ways can you arrange 5 tires if you include the spare? I'll give you 2 minutes, okay? Finish? Finish? Which way now? Good. Trey's done. Okay. Shayna, you good? What was 20B? 120. Right, if you're on track, 20B was 120 because it was what number factorial? 5, right? 4 tires plus a spare, 5 factorial. 120. Okay. Now, that is a one particular kind of permutation where the number of positions that we're filling is being filled by exactly that number of things. Most of the time, we're dealing with problems like this, where it says 10 students are in a race. First, second, and third places win medals. How many ways can the 10 runners finish first, second, and third? So there's only 3 positions to go into, but there's 10 to choose from. Okay, that's more normal. That is a permutation. Again, if you use the counting principle, you would say, well, let's see, there's 10 different runners that could get first place. Now, once somebody's got first place, how many runners could get second place? 9. All right, once you've got first and second given, filled, then 8 runners could be in third place. There's your 10 times 9 times 8, 720. But we actually have a formula for that. The formula is this here, right? I'll write it bigger here. N, lowercase letter n, capital letter P, lowercase letter r. Right? The n is the number that you're choosing from. It's the bigger of the two numbers. Right? So we're filling 3 positions from 10 students that are in a race. 10 is the n. Right? The number of positions we're filling is 3. So 3 is r. So as a permutation, it would look like this. It would be 10p3. And then if you follow their formula, the formula is n factorial over n minus r factorial. So in the numerator, it's 10 factorial. In the denominator, it's 10 minus 3 factorial, which is 10 factorial over 7 factorial. I mean, and I could show you that if I did that math up here, 10 factorial over 7 factorial. 10 factorial is 10 times 9 times 8 times 7 factorial. I'll let 7 factorial take care of everything else. And then it's still divided by 7 factorial. And the 7 factorials cancel, and all you got is 10 times 9 times 8, which is what we already did. Right? That's why that formula works. Now, we're not going to do that. We're not going to end up simplifying factorial expressions. We're not even going to be putting in the calculator, which we could, because now that you know how to do a factorial, it would be an easy thing to do 10 factorial divided by 7 factorial. What we're going to do is this. Go to the calculator. Go to the same menu, right? Math, PRB, and notice number 2 is the permutations. NPR. So that is what you're going to want to do. If you have to do a permutation, go there. Now, the way you enter it in the calculator, you probably need to see the first time. Okay, if I want to put in 10PR, first I do 10. On the main screen, put a 10. Then go to the math menu. Math, that was not math. Math, PRB, 2, and then put the 3, right? 10P3, 10 NPR, 3. So the calculator thinks that N is 10 and R is 3. And now when you hit enter, 720. Right, so if you have a situation that you want to do a permutation, that's where you go. And that's how you put it in the calculator. Okay, how could I write this as a permutation? Now we got 15 runners to finish first, second, and third. Right? It's going to be a capital P in the middle. What goes on either side? 15 and 3. So put that on the calculator. 15 math PRB 2 3. That's how many ways 15 people can fill 3 positions. Enter. 2,730. Good. Then go ahead and do this. Same page 21 to 24 and 29. Here's the 21 to 20. Oh, it should have been 23. I hope I didn't mess that up later. 21 to 23. 10 to the 10th. Okay. So you're getting a big number for that last one, huh? No, because see the e to the 10 at the end, that's scientific notation. That means if you move that decimal place over 10 times, that's a huge number. So yeah, if you get some kind of scientific notation on the last one, that's fine. That's right. Okay. So you're okay with permutations? Now, understand that what we did at the beginning where we said how many ways can I arrange 4 things, 10 things, that's also a permutation. Anytime order is important, that's a permutation. If for example, I want to put 7 books into 7 positions on a shelf, okay, well that's 7p7. Now, compare 7p7 to 7 factorial. 7p7, 7 math PRB 2, 7. 5,040. Now do 7 factorial. 7 math PRB 4. Enter. It's the same thing. Okay, so you could think of when you've got the same number of positions to fill as people filling them or things filling them, like that. You're filling 7 positions with 7 things. But it is still factorial. You could just run it with a factorial. Okay, now, if you read these two, in one of them, order is important. The other one, order is not important. First one, a chemistry teacher divides his class into 8 groups. Each group submits 1 drawing of the molecular structure of water. He will select 4 of the drawings to display. In how many different ways can he select the drawings? I don't like the way they state that, but you'll know after you read the second one for sure. You will draw winners from a total of 25 tickets in a raffle. The first ticket wins 100, the second ticket wins 50, and the third ticket wins $10. In how many different ways can you draw the 3 winning tickets? Right? Which one of these is order definitely important? The B, right? Because first, if you get it first, you win money, $50. You know, you don't win $50 with the second. So here, in the end, he's going to draw 4. It doesn't really matter which order he does it. He's just going to have 4. When you're drawing, when order is not important, then that's not a permutation anymore. That's called a combination. Okay? When order is not important. And these problems, I mean, if you have to do a calculation of a permutation or a combination or a factorial, as you can see, there's not much to it. Not with the calculator in your hand. There's not much to it. A lot of times, the harder part is deciding, is order important or not, so that you know which formula you're supposed to be using or which operation you're supposed to use. This is the permutation. NPR equals n factorial over n minus r factorial. Okay, here's combination. NCR equals n factorial over n minus r factorial, r factorial. So if you notice, the NCR formula is the same as the NPR formula, except it's got 1 more factorial in it, right there. And it's in the denominator. So it's going to always make the number of combinations less than the number of permutations. I mean, it'd be like me saying, how many different ways can I fill these 5 seats with you guys out here, right? How many different groups could I get? That would be a combination. If order was important, whether you were sitting there or there or there, then even for the same 5 people, I'm going to get 120 possibilities for those 5. And it's still the same group of people. So there's always going to be more permutations than combinations. And again, you could see that in the formula because there's something extra in the denominator for combinations. Now, if we go back to this chemistry teacher problem, he's drawing from a group of 8, and he's picking 4. So that is 8C4. So you go to the same menu in the calculator. Before you go there, put the 8. Works just like permutations. 8, math, PRB, and now 3 for NCR. And now I'll put the 4. So how many groups of 4 can I pick from 8? 70. So make sure you know how to put that in the calculator. Okay. So go ahead and do these. Right? Same page, 3032 plus 38, which is the word problem. What do you get for 32? 1, right? Just imagine what that's asking you. How many groups of 4 can you form from a group of 4? 1. If order is not important, then they're just 4 people, that's it. Not the same thing if you did permutations, right? That would be 4 factorial. Clear as mud? Yeah, that's the way we like it. To get the last one, 8 swimmers going to competition. How many groups of 3 can you pick for it? Okay. So as far as the lesson goes there, you have done everything up to 39 to 41. 39 to 41, they give you a scenario and say, which is it, permutation or combination? Meaning if order looks like it's important, you're going to say permutation. If order is not important, you're going to say combination, and then you're going to do the calculation. And I was just going to say, in this, the last thing we're going to do, which is, we have like two lessons plus a quiz to get to next time. We have to talk about something called standard deviation. We don't really go back and talk about mean, but I know you've done the mean before, haven't you? What is the mean of data? It's just the average. So in this, I got 5 sets of numbers here. What is the mean of the first set of numbers here? What is the mean of the second set of numbers? 3. What is the mean of the third set of numbers? 3. In every case, it's 3. Does that mean they're the same numbers? No, they're not. There's more variability in this one than there is in this one, and more in this one than there is in this. This has got none. It's still all the same thing. So beyond looking at, quiet please, beyond looking at what you've done before, which is called measures of central tendency, mean, median, and mode, you have to also look at how data is spread out when you're trying to make sense out of the data. And the thing that we look for is, well, we have to study a little bit next time so that then we can talk about normal distributions. It's something that's called the standard deviation, or the standard deviation from the mean. Well, what do you think we mean by a standard, or even a deviation from the mean? the difference from the mean, right? So if you look at these numbers here, if the mean is, and mean is represented by x bar, in all three of these, x bar is 3. If I subtract 3 minus 3 on all of these, what's the difference? It's 0 on every one of these, right? If I subtract the mean from all of these, what do I get? Right, this one I get -2, this one I get -1, 0, 1, and 2. Right, now what would I get if I tried to find the standard or the average of all these numbers here? Yeah, you'd get the -2 canceling with the 2 and the -1 canceling with the 1, and everything would be 0 again. And the same thing if I did to subtract here. -3, -3, -3. -2, -2, 0, 2, 2. Right? Everything cancels out. So as we're trying to come up with a way to represent how much data is spread out, you cannot just add up the deviations from the mean because they're going to cancel each other out every time. What you do is you take these numbers and you square them. Okay. Now what happens when you square the negative number? It becomes positive. It's not, and now when I add these things up, it is no longer going to cancel each other out. So when you add up, when you square the differences from the mean and add them up, that's called the variance. Okay. If I added these up, I get 4 plus 4 is 8, 10. Those add up to 10. That's called the variance. If I take the square root of that, that's the standard deviation. It's a complicated formula that we won't use much. What we'll do, again, like I said, most of what we do in this last couple days is in the calculator. Is you put them in the calculator, it runs the complicated formula for you. You know, one of the things that we've got to get smart on, again, which we were doing a lot in the first semester, was how do you enter data in the calculator? Stat, right? So stat. If I go to the stat and I hit edit, remember, you're going to put your numbers in these lists right here. If I just go, let's say, one at a time, I'm going to put in 3 5 times. 3, enter, 3, enter, 3, enter, 3, enter, 3, enter. Okay, if I want the calculator to find the mean and the variance and the standard deviation, then I do this. Stat, calc, 1. And you could see the mean, the x bar is right there. This last one, the sigma, it's a Greek letter sigma, x, that's the standard deviation. This one right here, sigma x squared, that's a variance. Okay, what happens if I change the numbers? I'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now, stat, calc, 1, enter. The mean is still 3. Now the standard deviation is 1.4, right? And it's not something you can look at it just like, oh, that's the average of the deviations. It's a kind of a complicated formula, but it is supposed to represent some measuring stick for how spread out your data is. And when we talk about normal distributions, we have to take into account 2 things: the mean, which you already know about, and the standard deviation. So we'll get what we can get out of that next time.